This is Twit.
Bandwidth for Know-How is brought to you by CashFly.
23andMe, a personalized genetic service based on the 23 pairs of chromosomes found in your DNA. For Valentine's Day this year, give that special someone the gift of knowledge. Go to 23andme.com and get $20 off when you buy before Valentine's Day. And buy
the Ring Video Doorbell. With Ring, you can see and talk to anyone at your door from anywhere in the world using your smartphone. It's like caller ID for your house. Go to ring.com/knowhow and get up to $150 off a Ring of Security kit with their limited time offer. On today's show,
You'll know how to Oscilloscope with Smitty.
welcome to Know-How. It's a Twitch show where we build, bend, break, and upgrade. I'm Father Robert Baldassare.
And I'm Brian Burnett.
And for the next however many minutes it takes, we've actually got a special project. You may remember not too long ago, we brought in the Oscilloscope, an oscilloscope project from a kit that we were going to assemble with the help of a very good friend. Let's bring him back. You know, people know who he is. You love him. He is the master of all things soldering. He is the one who tells you that your soldering job is bad and you should feel bad. It's Mark Smith. We know him as Smitty. Smitty Halibut. Smitty, welcome back.
Thank you. Hey, how y'all doing?
Pretty good, I think. You know, although it's been a couple of weeks since we did the Oscilloscope. Right. We wanted to let people get the kits, the people who actually wanted to assemble it. Now that we're assuming you've got it, because it's been 3 weeks, that's what we're building.
Together.
Oh, now Smitty, you have played with high-end oscilloscopes. I mean, you've got the ones that I used to play with when I was in university, which cost thousands or tens of thousands of dollars.
That I picked up for $40 at a flea market. Yeah, because all the technology has changed. Yeah,
it's all changed. How does this compare? I mean, is this actually usable, or if you're a professional, or you say this is a toy and I can't actually use this for real work?
So it is usable for low-frequency stuff. If you're doing audio work, or if you're trying to find like the source of a buzz in an audio circuit or something like that, it would be just fine. Where it's going to fall down is if you need to do some high-frequency work, like if you're looking at like a high-speed I2C bus or an SPI bus, or if you're trying to do any sort of radio work. It tops out at about 200 kilohertz, and I don't know where which is 0.2 megahertz. Which is a pretty dang low frequency for radio work.
Yeah.
And I don't really know what the noise figures are. It's probably not going to be fantabulous, but it's better than nothing. And it's good for a lot of very simple things.
Yeah, I actually did try hooking it up to a PWM generator, the little servo tester that I had from our quadcopter days. And that worked fine. You could actually see the signal pattern. But then when I hooked it up to the I2C bus, it just gave me very confusing information.
I guess it depends on how fast you're doing your I2C, but you should still be able to see the square waves. You're only just going to see like 2 or 3 bits on the screen at a time. You're just not going to be able to see enough of it to really be able to do any decoding or debugging or anything like that.
What if you live next to an AM radio station?
Well, if you live next to an AM broadcast radio station, you get that even when your probes are not hooked up to anything. I don't have a low pass filter on here. Yeah, I guess I would have to do a low pass on this because I'm measuring frequencies below the 890 kilohertz that is being broadcast at several thousands of watts, probably tens of thousands, if not hundreds of thousands, about a mile that way.
Right. Now
makes QRP hard.
Before we go any further, Kara, if you could show them the link to the kit. So this is the one that we use. There is a more advanced version that you could get, but if you want to follow along with us, $25, shipping is free. It'll get to you in about 3 weeks. I mean, Banggood does take its time, but it's actually a decent kit with decent instructions, and it was a lot of fun. I didn't actually blow any out. I had one I thought I killed, but it was just a really, really bad soldering.
Well, you do solder poorly.
I do, and I should feel bad. I do. Okay, now
and actually, I just to let you know, I got mine in about a week.
Really?
When I placed the order like the day that we did the last recording, and I had it within a week, and then I had it assembled the night I received it. So it didn't take that long.
It took me 2 episodes of Ghost in the Shell, which is about
2 episodes.
To get it shipped to you?
No. Yes. Yes, they teleported it to my house, Brian.
That's it's about an hour, right?
You have to pay extra for that. No, it took me about 2 episodes of Ghost in the Shell. I was stopping just to do other projects because I have the attention span of a flea. But once I actually got into the motion of doing everything, it was fun. Now, speaking of the motion of doing everything, Smitty, one of the things that I did, and I don't know if this is just me being OCD, was I actually sorted and measured all the resistors ahead of time.
Yeah, no, that's a good idea in this particular kit. Let's see if I can remember the values. This kit has both a 120 ohm 1% resistor, whose color code is brown, red, black, black, brown, and a 10K 1% resistor, which is brown, black, black, red, brown.
Oh, yeah, everybody memorizes that.
I mean, I don't know why that confused you. I had it.
Yeah, no problem.
But they're backwards from each other. You can't tell the difference by looking at the resistor, which one is which. So pre-measuring them ahead of time is critical. Otherwise, you are going to put the wrong one in the wrong place, like someone on this show may have done and needed to replace and like swap out.
And it doesn't work. It doesn't work if you put the wrong resistor in the wrong place.
No, it does not.
Let's step away from know-how for a bit and talk about something a bit more pressing. What are you going to get for that someone special in your life this Valentine's Day? It's not easy, is it? Flowers? Well, that's a good start. Chocolates? Been there, done that. A romantic dinner? Sure, that's a nice touch. But none of those things are really something special for that someone who's really special. But what if you could give a gift that isn't just a treat for the senses, but for the mind? I mean, you are a geek, right? I mean, you love knowledge, and your gift needs to say as much about you as it does about that special someone. That's why we're so happy to have 23andMe as a sponsor of Know How. 23andMe is the online, personalized genetic service named after the 23 pairs of chromosomes found in your DNA. With their genetic report, you can reach back more than 500 years and across 31 worldwide population centers to trace your ancestry to maternal and paternal haplogroups. Their ancestry service lets you track your genetics through history, letting you connect to people who share your DNA, even let you see how much Neanderthal DNA you've inherited. But it's not just history. 23andMe's Health and Ancestry Service gives you access to all their trait and carrier status reports. You can see how your DNA relates to caffeine consumption, lactose intolerance, muscle type, and more. It's a cornucopia of knowledge, real knowledge that has real-world applications, all for the taking. Simply provide 23andMe with a saliva sample in one of their testing kits, mail it back to the lab, and in no time at all, you'll unlock the vault of information that is your genetics. With over 65 genetic reports, your loved one will be sure to fall in love with their genetics at 23andMe. Just go to 23andme.com today. Buy before Valentine's Day to get $20 off. That's 23andme.com, 23andme.com. And we thank 23andMe for their support of Know How.
Now, this is a super cheap multimeter, Kara, if you go to my product shot. Super cheap multimeter. I got this thing like 20 years ago. It was $5, but it does measure resistance. So if I turn it down to this whole range here, that gives me the resistance of anything I connect the probes to. You definitely want to pick yourself up one of these. It will save you all that heartbreak of putting together a project and then realizing you've got the wrong resistor in the wrong place. So
the 100% must-have piece of test equipment is a multimeter like that. Measures voltage and resistance, at least. If you can get one that measures amps and various other things as well, better. But yeah, voltage and resistance are two must-haves.
Yeah, so this one will do DC volts, DC volts, AC volts. It will do DC amps, and then this is all resistance. So it's these aren't expensive, folks. If you should have one of these, you should have at least one of these in your kit. I actually have 3 of them, including one really expensive fluke that I never bring out because I'm afraid of breaking it because the thing costs like $5,000. But it's really for network testing. But okay, so what you want to do is I've got alligator clips that I've hooked up to my my probes. Really, really super simple. You want to pull one of the resistors. You just clip onto each. No, that's not a resistor. You clip onto each end. And this is how it works. So this is a smaller resistor. Notice if I do this and it stays at 1, it means it's because the resistor is out of range.
You know, you're on the diode right now. Put it on the correct range.
Yeah. So there we go. Right there. So it's even there. At 2K, it's out of range. At 1, it means it's out of range. So what I'm going to do is keep flipping this up until, there we go. Oh. So now at 200K, it's giving me 199.4 and 199.6. So this is a 200K resistor. You got that, Brian?
Yeah, no, that makes sense.
Now, if like, let me find a big one so I can show you the going the other way. Try to remember. Be Smitty. Remember these values. Okay, here we go. There should be a.
And there's only 2 kinds of different resistors in this kit?
There's only one type of resistor.
Oh.
Well, one type, but there's many values.
Yeah,
yes.
Yeah. So if I hook this up, there we go. See, that's 0.2. I can actually go back down. So now I know this is a 150. So not 150K, but 150 ohm resistor.
Ohms. Yep.
Okay.
Right?
And the first one was 200?
200K.
Okay.
200K,
Which is
so different. 200 ohm
Yeah.
and 200K. I mean, you're several orders of magnitude off.
Big difference?
Big difference.
Okay.
Now, here's what I did. Again, this is the OCD person inside of me. See this little kit here, Brian?
Yeah.
That's all the values of the resistors that are going to be in the kit. Now, what you need to do, and I know when you first get your kit, your tendency is going to be to tear into the package and just start jamming everything into the board. But Smitty will tell you, any work that you do now makes your work later so much easier. And if you separate it this way, you can actually compare this against the manual, and you can make sure that you've got all the resistors that you're supposed to have in the kit. There's nothing worse than getting to the end and missing one resistor.
And then
what does Adam Savage call it? Kerning or keen? Dang it! There's a term for this where you take all the parts out, and he always tweets pictures of people who like buy their Lego kit and they sort out all of the parts on their Lego kit. What's that called? Oh, it's killing me.
OCD. I call that. No. OCD.
It's like no, kerning is the spacing between letters. I don't remember what it is. There's a term for this.
I like kerning though. Well, I think we should start calling it kerning.
Yeah.
Okay, we've just
Hemming.
Kemming.
When you have never mind R and the N next to each other when you have bad kern. Forget it. Never mind. Sorry.
Okay, so here's what we're going to do. We're actually going to give Brian the task of separating out the resistors. You've got your own pack there.
Yes.
You're going to want to put them, and remember, it's like when it says 180, that is literally 180. Not one. That's different than 1.8 M, which is million ohms. So just know that, mega ohms.
How many different values are there?
Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 13, 14, 15 values of resistors.
Okay. All right. Challenge accepted.
Here you go. Let's let Smitty throw his either approval or his disgusted look in your direction.
I thought he was holding up a sad face.
And actually, no, this is important because you want that sheet in front of you.
Okay.
Because as you measure, just make sure your measurement matches one of those resistors.
I see.
And the way I've organized it in that box, it goes from the lowest value is at the top left,
120,
and the highest value
2
is
million.
There we go.
You have to put your pinky up to the side of your mouth. 2 million ohms.
Million ohms. So if you go ahead and start separating that, what I'm going to do is I'm going to start soldering a couple of components. Now, Smitty, when you're soldering, you do follow an order, right? I mean, the instructions give you an order of which component should go in first. What's typically your way of proceeding?
So I typically go with, well, there are two different schools of thought. If it's a complex system, complex circuit, and usually if I've designed it and I don't trust myself, I will often build like the power supply first without all the rest of the stuff on the board, test out that section of the board, then I'll go build the next part of the board, test out that part of the board, and so on and so forth. And if I understand what's going on and I know the different components of it, I'll test out each of the components as I go along. And when I say component, I don't mean resistor. I mean like sections of the schematic. In this particular case, I don't have that kind of detailed knowledge of what's going on, so I just do the whole thing at once. So in that regard, the other philosophy is start with all the components that are low and small against the board. Small components first, low against the board, because it's a lot easier to put in a tall thing next to a skinny thing than it is to put in a skinny thing next to a tall thing.
Right.
So it's just a physical assembly thing, getting my big fat sausage fingers into the board and making the pins get in the holes and all that fun stuff.
And this board definitely has that because it's got the pin connectors so that you can connect the LCD screen. If you put that in first, all the components right next to it you have to put them in with tweezers, and it is an absolute pain. And I say that because
from prior knowledge.
Not on this kit, but I've done it before.
Yeah.
All right. So these are all the resistors I've got, Brian. Now, there is another way to do this if you're really, really impatient and you absolutely cannot wait. What you can do is this. So you take your multimeter and go ahead and measure, let's say this resistor right here. I'm going to get a value for this resistor, and then I'm going to compare it against the instructions for where it should go on the board. So, for example, this one is 122 or 120 ohms. Now, should I be worried that I have resistors that kind of fluctuate? I mean, this is not a super sensitive multitester.
No, and neither are your leads, and you're talking about the difference of 1 ohm. The resistance in the leads themselves, and as you move the leads around and crack the cables and whatnot, I mean, you'll get half an ohm to an ohm, maybe even a few ohms if they're bad, variation in that. So no, I wouldn't worry about that at all.
Right. What about the ultra precision ones? So when they make an ultra precision resistor, what does that mean?
So So most cheap resistors are what are called 5% precision. So the value, if it says 120 ohms, it could actually be 5% less than that or 5% greater than that, and they'll still accept it as a in-range resistor. These are all 1%, and I don't know if that's just because 1% is the new 5% and they're cheap and they're easy to get a hold of, or if they actually need that kind of precision. I'm not entirely sure. But the precision just means like how close to the stated, the nominal value of the resistor is the resistor guaranteed to be.
Right. So on this one, of course, if you go back to my product cam, we've got 120 ohms. So I'm going to go ahead and pull that off of my leads. Just remember that. Now I can look at the instructions, and on the instructions I can find out 120 ohm resistors are required. See. On 4 different spots, R8, R12, or 3 spots, R8, R12, and R13. If I wanted to skip the organizing step, which I really, really would not recommend, I can just put this directly into R8, which is right somewhere here. So I'm going to do a little U-bend on this thing. How do you U-bend your components?
Me?
Yeah.
I just kind of
bend them.
The wires.
You don't like use any tool or anything.
Oh God, no.
Okay.
No.
So now this resistor's there. I'm going to give it a little tiny bend just to make sure it stays in there. Smitty, I've seen some people before who will do this. They'll actually put it down.
Yeah, that's not necessary, and that makes it harder to trim the wires later.
Right? Yeah, because then you have to bend them back up when you want to trim.
Yeah, and actually, what you've done is you've splayed the wires out so far that they're gonna be much larger and much more likely to be shorting out against something nearby.
Precisely. Okay, so I'm going to be doing that, and I just go down the list and go ahead and start soldering them in here.
And I would check them off with a
Go
pen.
ahead. Okay, Brian. Let's. Smitty's got to check your technique. So show us your stuff.
My technique of
measure
checking...
some resistors for us.
It sounds pretty difficult from what you showed me.
So no, measuring resistors is easy.
Yeah, I was being facetious.
I have a confession, Padre. I assemble the way you just described it. I just grab a resistor, either look at it or measure it, figure out where it goes on the board, install it, lather, rinse, repeat. Right. I'll usually put 3 or 4 on the board at a time and solder them all up, trim them all, and then do the next batch.
What you doing there, Brian?
You're moving back here, let me move this into the camera. I'm trying to... All right, so 1, that means it's not...
It's out of range.
Right, so 20...
Okay, there you go.
So 9.98.
So which is close. Look at your list. Now look at your list, and there is no 9.98 K.
Right.
So it's going to be
the next one up.
Well, no. You got it. But now look at your list. If there's no 9.98 K, the closest
round the value.
Oh, okay, 10K.
There's a 10K, so that goes to the 10K bin. Okay. Now here's Smitty. I'm going to make a confession. I did it 2 ways. One, I used the bin. The other, I went straight in.
Oh yeah.
So I've done it that way.
And both of them worked?
Both of them worked.
Yeah. No, there's really no reason not to. As long as you're making sure that the right component is in the right place. Well, I mean, it's quicker if you just grab the resistor, figure out which one it is, and put it in the right spot, because then you don't have to do all the sorting out. Where the sorting out stuff really comes in handy is if you're not sure you've got all the parts, or you want to make sure you have all of the parts. Or if, like in this case, there are a couple of values that look very similar and you need to figure out which ones are which ahead of time, those kinds of things. But resistors are pretty simple, especially with a meter on hand. So I just assemble them straight away.
And the other thing, this is best practices. If you do the box method, you really should measure it again once you take it out of the box before you put it into the board. I'm sorry, but it's just, it's better to catch it before you solder it onto the board.
I don't know what you're talking about.
Well, I mean, that process actually kind of caters to my OCD part. So I actually enjoyed it. I enjoyed sorting them, and then I enjoyed testing them again before I put them on the board.
Knolling. That's the term.
Knolling. Thank you. Knolling.
Is that an acronym or
No, that's just.
I have no idea. I see Adam tweeting people about how their kids knolled their toys this morning. Some kid knolled his breakfast cereal. Whatever. Apparently it's something he talked about on Tested or MythBusters. I'm not sure which. And everybody's tweeting pictures to him of them knolling their stuff.
Right. And once you've got it, just retest it again. Just again, one extra 10-second process can save you hours of troubleshooting later on.
Yeah.
All right. So I've got my soldering iron back up to heat here. There we go. So we all know this process because I've got the 2 pins slightly bent out, slightly splayed. They're going to stay on the bottom of this, and so I can just heat the pad and the pin, not the solder. And as soon as it gets warm enough, it's gonna. There you go.
Yep.
Like so.
Perfect. Yeah. Well done.
And so with the resistors, it doesn't matter which way you put them in, but
correct.
It's the capacitors that
some of the capacitors. So the ones that look like little discs doesn't matter which way you put those in, but the ones that look like little barrels, those have a polarity.
Right, because there's one lead that's shorter than the other, and that's kind of like LEDs too.
Right, and the instructions are really good about telling you which pin goes into which hole.
Yeah.
Yeah. Now
I am rubbish at remembering lead lengths because I think it varies from component to component. On the capacitors, the way you tell is by the stripe with the negative signs on one side. Unfortunately, the capacitor says this is my negative pin, and the board says this is where the positive pin goes. I don't understand why they've done that convention.
Right.
But yeah.
They did.
Anyway.
But they did.
Smitty,
let me ask you this. One of the things that I got used to doing is I don't like a lot of slack in the components. I actually like them to be flush against the board. So I will take either pliers or if I can be fast, I'll use my fingers and just kind of reflow the solder and then pull it up just to make sure it's snug. Do you do that?
Oh, I do it the other way around. I push it from the other side with my I push the component.
That works too,
yes,
you can get
I do
both
that
sides.
too. It's more critical with surface mount components because you don't want the surface mount components to be kind of floating. You want them flush with the board.
Yeah, which we will be doing. Actually, we're going to be doing it with you. We're going to be doing a kit that is nothing but SMD and has literally, 400 joints you have to make. And it's fun. You were absolutely right. I was so afraid of SMD. Which is why I got this kit. But once you get the technique down, it's actually easier than through-hole.
Yeah, because you're not flipping the board over all the time.
Yeah, Brian, how you doing over there?
I'm quicker with SMD.
I still got quite a pile of resistors over here.
Kind of happy? Kind of happy?
I'm enjoying kind of going through them and analyzing each one. But okay, so when I go to, if you go to my product shot again real quick, that's Padre. 469. So
469 at 2K.
At 2K, right.
There you go. So that's what?
So 470, I guess, would be rounding it up. But okay, 470 ohm. Yep.
There you go.
Okay.
There you got it.
Cool.
All right. That sliding scale can kind of throw you.
Yeah.
But just remember where you are. If it's 2K and it's showing you, point something, then it's under 2K, right?
Okay.
It's under 1K. It's actually half a K. Then there you go.
There we go.
Nice
okay, cool.
Now, Smitty, when we come back, I actually did have a task for Brian. Brian, what I need you to do is there's actually multiple parts of this kit, including this screen. So what I need you to do is I need you to solder. There's 3 sets of pins that you have to add to this so it can be attached to the board.
Okay, right.
Okay, so
you want me to do it on yours and not my kit?
Well, I'd rather you break mine than break yours.
I appreciate that.
Oh, come on. Show a little love and trust in this guy.
No, he'll be fine. He's a good guy.
No, okay, so Brian, I'm going to override Padre on this one. I think you should go solder your own because it's yours and you made it.
Maybe I should.
And if you break it, then you can trade with Padre.
Okay.
Okay, but just real quickly. So what you want to do is you want to use this side. So this is the connector, and the shorter ends
Short end
go
the
in
board.
like this.
Okay.
And then you're just going to solder along the top. Smitty, do you want to give him any advice on how he's going to do that?
Yes, absolutely. So the boards, this is less of a problem because it's got the 2 rows of pins and it'll sit flush with the board pretty easily. Mm-hmm. But you want to make sure that connector is very much flush with the board. And the way I do that is I will usually hold the connector on one side with my thumb and then solder a pin on the other side just to kind of, when I say like the end, the long way, you know, so you've got your thumb holding on one side, and then you solder a pin on the other side just to hold it in place. And then, like Padre was saying, you can kind of make sure it's flush and reflow that first pin to make darn sure that everything's flush. And then on something this long, because it can kind of flex, I would also solder a pin on the other side to hold it in place. And now you're holding it on both ends of the connector. Okay. And then after it's held in place like that, then you just zip right across on every single one.
Okay. And are we doing both sides of those plates or just the
no? You just have to do the back side.
Okay. Just the solder side, but you do need to do both rows.
Okay, that's what I meant.
Yeah. So what happened was I tacked this top pin and this bottom pin on the other side. That connector's not going anywhere.
Right.
And if I'm happy with how it looks, see how it's flush with the board. There's no space between the connector and the board. Then I can just go right down the line. And remember, you want to heat, not the solder. You're not heating the solder. You're heating the pin
pad.
And the pad, just like that. And you're going to wait till it flows. You only need a very small amount. And yeah, there you go.
Yep.
All right. Okay. Cool. We'll check it out.
Little quick recommendation. If since you're going to be going down the row, your solder is going to get shorter and shorter every time you tack another pin. So what I recommend is starting, you know, farthest away from your solder. If this is my solder finger, solder here and then you do it, and then go to this one and go to this one and go like that, because then the solder is working shorter toward your hand. Whereas if you do it the other way, you're going to have to be constantly pulling more solder out.
I see. Okay.
You ready for this challenge?
I'm ready for this challenge. I'll move the resistors out of my way for the time
Now,
being.
while he's moving those resistors, let's go ahead and take a moment to thank the sponsor of this episode of Know How. Now, I love talking about the sponsors because they're the ones who allow us to continue doing the shows. But whenever I can talk about a sponsor that I bought whose product I bought way before they became a sponsor, it's something special. And that's what I get with Ring. Now, if you've ever watched Twit, you know what Ring is. Ring is a company that makes appliances, these network-connected appliances that give you added security. Now, the Ring Video Doorbell was the original, and it is a fantastic piece of gear. It replaces the doorbell that you have, and it gives you a two-way communication with anyone who might come up to your door. You know what call waiting is? Well, imagine call waiting, but for your house. Oh, it's got a motion detector as well as a high-definition camera and a speaker and a microphone. So when someone comes to your doorbell and announces themselves, you can start a two-way conversation with them. You can see who they are, even if you're not in the house, even if you're halfway around the planet. That's what Ring can do for you. Now, the Ring Video Doorbell has been proven to stop burglaries before they happen. It allows you to see and speak to anyone approaching your door using your smartphone or your tablet. Now, Ring is using their advanced motion detection technology to protect not just your door, but your entire property. They've got these Ring of Security kits. Now, all the kits are going to include a Ring Video Doorbell and a solar security sign, and they may include a stick-up cam, a solar panel, or a chime. The Pro kits have a Slim Video Doorbell Pro with crystal clear 1080p HD video and night vision, and it's hardwired so you never have to charge it. The wireless and weatherproof HD stick-up cam keeps an eye on other parts of your property and allows you to hear and speak to visitors with two-way talk. Imagine putting one in the back so anytime someone comes through your backyard, you can get a notification that it's detected motion, and then you could just ask, hey, what are you doing in my backyard? Now, the illuminated solar sign deters intruders before they get to your door. It's that whole don't be the lowest hanging fruit and you're not going to attract burglars. The Ring Video Doorbell and stick-up cam install in just minutes, and working together, they provide 24/7 monitoring of your entire home, whether you're in your bedroom or thousands of miles away. You can also connect your Ring Video Doorbell with your favorite smart locks and hubs for added convenience, monitoring, and security. Now, I bought a Ring Video Doorbell for my parents in Las Vegas because I was a little worried. They were getting, an odd number of burglaries because they live in an area with a lot of elderly people, and the burglars had figured out that around noon, the people went to the club. And if they're at the club, they could knock on the door, they could ring the bell. If no one comes, they would break a window and be in and out in 10 minutes. I didn't want that to happen to my parents. I didn't like the idea of leaving them out there without at least a little bit of security. And so now, with the Ring Video Doorbell, we've been able to catch not just people across the street who are stealing packages, but we caught a neighbor who was trying to steal power during the summer. Folks, if I trust my parents with the Ring Video Doorbell, I think you'll just love it. Join the millions of homeowners who protect their home with Ring. For a limited time, Know How listeners can get up to $150 off one of Ring's Ring of Security kits. Go to ring.com/knowhow. That's ring.com/knowhow. And we thank Ring for their support of Know How. How you doing over there, Brian?
I'm getting prepared to make my first incision. I mean, soldering.
Okay. Quick thing. Remember,
Why are we always preparing? Just go.
That's
Sorry.
Stargate. That was an episode.
No,
with-
Spaceballs.
Oh, Spaceballs. Oh, sorry. So Brian, remember I told you about this in the morning. If you're going to hold the pins, you don't want to hold the pin
The ones that
I'm
I'm going to be soldering.
Yeah, just
I could use a third hand.
Yeah, there you go.
Yeah.
Okay. Now, hey, Smitty.
Yes, sir.
I love this stuff. I love it dearly. But one of the things that I've always wanted to do is to have something like a 3D printer, but for electronics. Have you looked into that?
I've not done a lot of research, but I know they exist. Actually, there was a company demoing their product at CES this year. Did you see them?
Which one?
I don't remember the name. I've got a flyer around here somewhere, but it's about the size of a desktop 3D printer, and they've got like this little inkjet head that squirts out an inkjet, kind of a metallic inkjet ink that you can print traces directly onto either a flexible like Kapton or onto a FR4 circuit board. And then they have like this metallic epoxy stuff. It's not quite soldering, but it's an epoxy, and it's like an integrated inkjet printer, epoxy squirter, and pick and place machine all in one unit. And so you just put down like an empty board and line up all of your components on one side, and it just prints out your circuit and then puts all the components in. And then the epoxy, I think you need to heat it for the epoxy. I don't remember exactly how that works. And out pops a board.
It's actually a fascinating process, especially if you're one of these people who has to send stuff away to prototype. Did you do the whole thing?
I didn't do the whole thing, but do you think it's flush enough on the board?
Yeah, you done good.
Okay, cool.
Good job.
Yeah, I tacked both sides of it so
How about
far.
that? Smitty, I think you and I are actually talking about the same unit. I saw some folks from a company called Voltera, and that's exactly what they had built. It was sort of an inkjet printer that allowed you to create circuits and then have it lay down components and lay down solder. We saw them at World Maker Faire. What we're going to do is we're going to continue with soldering, but for the next couple of minutes, why don't you take a look at what Brian and I saw at World Maker Faire. Don't you wish it was as easy to print a circuit board as it is to print a 3D object? Well, with Voltera, it is. I'm speaking with Alroy, who's going to explain what the V1 can do for your makerspace. Alroy, what's the idea behind the V1?
Well, it all started when we got really excited about 3D printers, but we're all electrical guys, and we said, where's our rapid prototyping tool? How do we get, circuit boards, right away instead of sending them out to a factory and waiting for weeks for them to arrive? So that's what led us down the path to creating the Voltera V1. And so right now we've built this amazing printer that can print circuit boards right from your desktop in an hour rather than sending them out.
What I love about this is some of these are, if you're a maker, these are readily recognizable. If you look at this board, you think, oh yeah, that's an Arduino Nano. I've seen those. I bought a bunch of those from eBay, clones from China. But now I can actually make it inside the comfort of my own lab. I can order the components. I can assemble it exactly the way it needs to be without having to wait for lead times of these prototyping shots. Tell me, what's the process? What do I need to make this work? How do I design my boards? What kind of consumables am I going to be looking at?
Yeah. So you can design your circuits in whatever CAD tool you're already comfortable with. We take Gerber files as the input. So you just drag and drop them into our software and go through a little quick calibration step and then print. And the ink that we use is a silver nanoparticle-based conductive ink. And so we lay that down based on what your Gerber files dictate. There's a short curing cycle. After that, you swap off the conductive ink, throw on solder paste. We've got a cartridge for that as well. It'll dispense paste on all the pads. And we also have a 500-watt heater that'll reflow your entire board for you. And we can do that on boards that you printed on the V1 or boards that you got fabbed at a factory. Either way, we're just trying to help get rid of stencils, get rid of breadboards, get people building actual electronics quicker, faster, and better than ever before.
So this really is a one-stop shop. I can draw my board, I can put down the paste, I can place the components and reflow it all within the V1.
That's right, yeah.
Okay, now guide me through the cartridge thing. So you've got several cartridges. This is magnetically held inside of it. Yeah. How do I swap it out? What do I need to do during the process?
Yeah. So I can lean over here and show you. We wanted to make the printer itself as stupidly simple to use as possible. It literally got one power button on the front, and then these magnetically swappable print heads. So we have one for the conductive ink, one for the solder paste, and it's as simple as that. Everything else is pushed into our software package, where even there, the same sort of design principles are reflected, where we're trying to make it as intuitive to use the tool and the software as possible, so people are focusing on designing great stuff, not on learning how to level a bed or do all these different things. So in our software, we literally have videos playing alongside, saying, now do this, now take this cartridge off, now clamp your board down, because it just makes getting up and running, a breeze.
Let's talk about that learning curve a little bit, because one of the things that really sped up the development of 3D printing was things like Thingiverse, and on all these sites where you could share designs with other people who could take your design, maybe tweak it a little bit, and make it their own. Are you thinking about creating something like that for the Voltera community, where designs that people are proud of can be shared? People can take, say, my custom Arduino board, my custom Atmel board, and then make a couple of changes and make it for their application.
That's already starting to happen on our forums right now. We've got all the people that currently have a V1 are out there printing stuff, sharing designs, and getting other people to build them too. And some pretty cool stuff is coming out of it. We just had somebody print a 915 megahertz antenna and was doing some wireless stuff. So it's, honestly, that's what we get up for in the morning, is to check the forums and see what people are doing, what they're building. And it's amazing to see this community start to grow over the last few months. It's insane.
All right, the big question is going to be pricing and availability. If they're enticed by what they've seen, if they think that maybe they want one of these in their maker shop so they can fast prototype all their boards, where do they go? How much is it going to cost?
So www.voltera.io, VOLTERA.io. We're already done fulfilling our Kickstarter. We are shipping as orders come in now. And so the printer itself is $21.99. That comes with the printer, the conductive ink, the solder paste, all the boards and accessories you need to get started. So yeah, get them while they're still there.
Roy, thank you so very much. And thank you for making something that I think it's got a niche in the maker community that I think needed to be filled. Folks, here at Voltera, you can dream it, you can design it, you can build it, and then just print it.
I really, really, really like that thing. I asked them for a demo model. I just want to see how it works, because I've always dreamt of being able to have a finished board, not a breadboard, but a finished board, the same night I had the idea.
The fact that you can swap out the solder, the cool. ink, basically ink, that was the part I liked.
Yeah, and it's relatively affordable, relatively.
$2,100 is not, that's within the range of a makerspace or a way too wealthy hobbyist, right? We're not talking 5 or 6 digits, which a lot of that stuff used to be, right?
Right, exactly.
So that is not the one I was looking at. That one looks much nicer than the one that I saw.
Okay, well, I'll hook you up with the Voltera guys too. Now, Brian, how have you been? You've been soldering furiously since...
like a madman, I've been soldering.
Let's take a look. What you got?
Let's see. So I'll show you which ones I've finished. It's kind of hard to tell on the camera, but I've done the whole close row, and then I'm making my way down this way on this one.
Wow, that's really good. Okay, I've done a little bit of work myself. If you go over to my product shot, so this is as far as I've gotten. So a little faster, but it's cool.
Oh yeah, that whole thing.
This is the whole thing.
No big deal.
Yeah. Well, no, actually, this is not the whole thing. These are all the components that don't have polarity, aside from the crystal. The crystal also doesn't have polarity, but the other capacitors that do have polarity, the chokes, I haven't put those in yet. Now, Smitty, I did want to ask you though. So when I've got something like this, go back to the product shot, the underside,
the Cthulhu squid of wires sticking out of the bottom of your board.
Do you cut as you go, or do you wait until you have the salad?
No, I like I said, I do a few components at a time. I'll usually put anywhere between 2 and 8 resistors in the board at a time, and when I flip it over to go solder those, I will trim them as soon as I'm done soldering them. They just get in the way.
Yeah. And how far do you trim them down? Do you go
as
all the
flat
way?
as you can get against the board?
Is there a special tool for this? Because my diagonal cutters, they don't get me all the way down to the board.
So if those look like pretty large diagonal cutters, there are much smaller ones, and also ones that are not magnetic, so that the parts don't try to stick to the tool.
That would come in very handy right about now. Hold on.
Yeah, I've got some really nice flush diagonal cutters. If you look at the bottom of those diagonal cutters, I bet you they're still angled a little bit before they go to the blade. The ones that I have are flush all the way across, and it's actually usually taking off the top bit of the solder as well from the solder pad.
I actually had a set that was specifically designed to cut away the ends here, but it walked away from my table at the last DEF CON.
Walked away, huh?
It walked away.
Yeah.
And you know what? I still believe it was just someone who totally forgot that they had borrowed it. I'd like to believe that there wasn't someone who was just like, yeah, I'm going to steal this.
Probably.
Yeah, most people at DEF CON are good-hearted. There are a couple of jerks, but, that happens everywhere.
I'm right here, Padre.
I didn't want to say you, Smitty, but okay, fine. Let's go.
Well, there's a reason why Padre's not going this year.
Yeah.
You're not going either?
I can't.
I
can't.
Yeah.
I really want to. I haven't missed a DEF CON in so long, and I'm going to have to miss probably the next two.
I think my creative juices are flowing in different directions, so I think I'm probably going to skip out. This might be my last year, and then I think I'm going to skip after that.
Are you thinking?
I kind of want to be there for 25 if I can.
Yeah. But you're going to come back, right? I mean, it's your last year for a while, or you're kind of done with it?
I am going to play it by ear. I'm not saying never again, but I also... It's kind of like Maker Faire. The first year I went to Maker Faire, I was like, oh my God, this is so awesome. And then I went back the next year, I'm like, this is still really cool, but it's kind of the same stuff.
Yeah.
And then I went back the third year and I'm like, okay, can we get a little bit of variety? And it's really cool. It's not any less cool. I was just looking for, the new cool stuff that gave me that sense of amazement and wonder in, holy cats, look at all this awesome stuff. And I'm like, yeah, this is, 70 to 80% the same awesome stuff I saw last year.
That's kind of like how CES is. You see the same companies, the same exhibits over and over, and literally the same people because they hire the same presentation folk across different companies. And yeah, it gets old.
Yeah, but I could have spent another couple of days in the Hi-Fi Man listening room upstairs.
That's different because if you find something that is your thing, your niche at CES, that's awesome. That's fantastic.
Yep. So Padre, will you evaluate? I mean, I don't think it's the prettiest. There's a few blobs on there, but it should function, right?
Okay, so there is something that you should do here. Now, normally I have my magnifying glass. Totally forgot it, so instead...
You got those awesome glasses.
These awesome glasses. What you can do is you can actually use one of these to take a look at the solder joints. What you're looking for is you want to make sure you're actually contacting the pad, and you don't have to have these on your head. You could actually do this. You just want to make sure there's not a gap between the pin and the board.
Right. Okay.
So
do an inspection.
No, it looks pretty good. No, you're fine. No, seriously. Smitty would tell you that that's an excellent job.
And that I should go home
and you should go home and feel good about yourself.
Feel bad about yourself.
You should feel... Smitty wants people to feel good.
I do.
That's true. We give Smitty a bad time just because we feel bad.
We feel
Not
bad.
that he necessarily made us
we just feel like we've let down our spirit animal.
It's true.
Well, yeah, so I mean, recently on Twitter, I confessed that I have not yet seen Ghost in the Shell, and you're like, dude, what? Really?
Everyone's seen. Even Kara has seen Ghost in the Shell.
You slaughter bad.
And she's not a geek.
I find that hard to believe.
Oh, I've totally seen it.
Yeah, I haven't.
Kara was
really a big guy.
We went to Maker Faire, and we got an interview with Adam Savage.
My best friend.
And Kara's like,
seriously? Nice.
No.
I like him. He believes me.
And then after that, oh no, we're totally tight. Yeah, I know Adam Savage. Oh,
the
that
guy from Mythbusters.
That Adam Savage. Oh, okay, yeah. All right, so Smitty, we've got a bunch of these capacitors. If you go to my product cam, you can get a little close up.
Electrolytic cans.
Electrolytic. So these are polarity sensitive. There is a positive end and a negative end, and the positive end is a longer lead, and the negative end is a shorter lead. Now,
Carol, take for it.
These are all what? It's a 100. Is it picofarad? Is that how you measure them?
Probably not. Electrolytics are almost always microfarads.
Oh, okay, microfarads.
Duh.
But it's good. Duh, Padre.
Okay.
Gosh. But no, I mean, it should say right on the side of the can. Get your loop glasses back out again. They'll list a voltage rating and a value.
Oh yeah, 16 volts and 100.
100 microfarads.
100 microfarads. Okay, so on the board, you're going to see them. You see, again, if we look at the instructions, C19, C21, C22, C24, C25, and C26. And I've got 6 of these here, so I can actually put them all in at the same time. If you look at the board, one of them has a square pad, one of them has a circle pad. So you always want to put the longer lead through the square pad because that's going to be the longer, I mean, that's going to be the positive side of it. Like so, and like so.
Yeah. Again, I never remember long versus short lead. I just look at the minus sign on the side of the can.
That's
the stripe
also,
on the
that's a dead giveaway.
So Padre, I've got the long connector on there, and then it looks like there's 2 smaller ones.
There's 2 smaller ones. The 2 smaller ones are actually just this, so you need to take this one and break off 2 and 2.
I see it, like these. Okay.
Just snap them.
All right.
That's what they do.
You actually are intended to break something.
Yay!
I'm good at that. Woohoo! Smitty, if I'm not saying I've ever done this, but if like last week I install one of these backwards, what happens to a cap? One of these caps if I run voltage to it in the reverse?
If you do it for a little bit and you catch it quick enough, and you're not doing a huge amount of voltage, then it'll heat up, and it might start leaking, but you can probably pull it out and not break anything. If you do it with a lot of high voltage and you do it too much or too quickly or for too long, you'll actually break the can. It'll start leaking all over the place, and bad things happen. And yeah,
I'm sorry, I have to go to the other side of the table because Brian just used the diagonal cutters to cut that, and those connectors are now gone.
It's gone.
The cutters are?
No.
So he snipped off 2 pieces.
If you go to the product shot.
Yeah, you kind of want to hold those when you're cutting them.
I just went.
You can do it with your fingers if you just put your fingernail in that second indent and just
kind of bend.
I actually use pliers.
Now I took 3 off.
Yeah.
Are there extras?
Cut off. Well, you can use mine.
Am I supposed to use all of these?
Use all of them, Brian.
Oh, I already lost them. This is terrible.
Now, Smitty, as in terms of difficulty rating, we've got. You
need some extras?
Oh, jeez. I know. I have the same thing from my quadcopter days. I've got a big bag of pins.
He just went across the table again.
Okay, All
right. Well, I've got 2 now.
Maybe you should be wearing safety glasses.
Yeah, I shot that way, so I'm okay.
Do you wear safety glasses when you solder, Smitty?
I've got my normal glasses on. I don't put anything else on top.
The other thing is, should I be concerned about soldering fumes?
So there are a couple of different things about solder that can be a little dangerous. One, the fumes you're seeing are actually the rosin that's melting. That solder that you have there is not a wire. It's not solid all the way through. It's actually a little tube, and in the middle is some goo called rosin. That rosin, or also known as flux, when it heats up, it kind of cleans off all of the components, the surfaces that are being soldered to, and it deoxidizes them, and it makes the solder flow much better.
Question. When you're done, sorry. Go ahead and finish. I have a question when you're done.
So the fumes that you're seeing are actually the rosin burning, and it's not going to be good. I mean, I don't know, Prime is saying about it, the smoke from the flux is filling his lungs. He's earning minimum wage. I mean, that was back in the 90s. Flux inhalation has been around for a very long time, and you don't hear people bemoaning it. So I think you'll be okay there. If you really want, you can set up a little fan. They make these things that's a fan that kind of sucks air through, and it's got a little activated carbon filter that you suck air through, like the fumes from your soldering through that, and it kind of cleans it out of the air.
Yeah, I have a little 3D printed thing I did with a 12-inch or 5-inch fan. It works really well.
Yeah. The other thing that you have to worry about, I'm assuming you're using good old-fashioned leaded solder there.
That was my question. Is because
I can tell because it tastes better.
Yeah, it does taste better.
It's delicious.
Lead is so much better. I mean, in the United States.
So there is a difference.
Yes, there is absolutely a difference. Leaded solder is a lot easier to work with. Having said that, it is also not RoHS compliant, RoHS. I don't know what it stands for. It's basically the electronics industry saying, we got a lot of lead floating around in our stuff. And when people throw this stuff away, it ends up in our water supply, and that's bad. And the people who are assembling it have lead on their fingers, and that's bad. And we should probably just do away with this lead. And so they kind of came up with a new formulation of solder that's mostly silver-based, if I remember correctly. And it melts at a higher temperature, so you've got to get your components hotter before it will start flowing, and it doesn't flow quite as easily. Leaded solder will definitely make a nicer and cleaner and easier solder joint, but lead-free solder is, going to be less bad. Now, having said that, I don't know about you, but I've got pretty thick calluses on my fingers. I'm not too worried about absorbing lead through my fingers, and as long as you wash your hands before you put food in your mouth or whatever after having soldered, you'll probably be fine.
So I've
been using leaded solder for years, and nothing's been a problem for me.
Well, can you still buy leaded solder, or do you have to go on okay?
This is leaded solder. You're using leaded solder right now.
I know. I just wasn't sure if they stopped making it and you have to hoard it and decide on eBay.
60-40. So this is 60-40 lead to tin.
Okay.
Lead to tin. Okay.
So are we criminals right now then?
What?
Are we not supposed to be using leaded solder on these?
No. The U.S. has not outlawed leaded solder. The EU has. You're not allowed to make an electronic component that has lead in the EU. And there are probably a bunch of other places in the world that have done the same. But, the United States, we apparently don't care about the environment. So
hey, we'll get there eventually. All right. Yeah. So, of course, being this a cooking show, we did the traditional cooking thing, which is we pre-baked something so that we can actually show people what it's going to do. Now, this is the one that I assembled the other night. Let me get some power here. There we go.
Unlimited power.
Now, Smitty, what am I going to be able to measure with this bad boy?
I don't know. What do you have that needs measuring? I mean, a lot of analog circuits, you'll be able to measure. I mean, I think it'll go up to 10 volts, 20 volts?
Yep.
I don't remember what the maximum voltage range is, but you could use it to look at, microphone audio, line level audio, speaker level audio.
Let's run through some of the functions really quickly. So here, I can change between AC and DC or ground. Typically, I'm going to be leaving that on DC. This
not always, actually, pretty rarely.
Really? What do you leave it on?
AC. Well, it depends on what I'm looking at.
Oh, right.
Go ahead.
This is so I've got 1 volt, I've got 1/10 of a volt, and then I've got 10 millivolts. So I can switch between those 3 positions. And then down below, this is my my scale. So I've got ×5, ×2, and ×1, and that multiplies what this is. So if I'm measuring 1 volt and I put it on 5, it's actually measuring 5 volts each unit.
And to be clear, that's 5 volts per division on the screen.
Right, exactly. It doesn't mean I can only measure 5 volts. It means I'm making the units either bigger or smaller.
Correct.
Yeah. Now, as far as the buttons over here, this button does a couple of things. If I press it once, what it will do is it will hold. So if I'm trying to look at a wave and it's moving really quickly, I can just do that and freeze it so I can actually measure what it's doing. If I press and hold this button, what it will do is it will either add or take away that little menu here, which is actually giving me like frequency, cycle, duty, voltage max and min. That's all available for you, but you can take it away if you think it's getting in the way of you actually doing work. Here,
Padre is showing this to you because he just found this out before starting recording this show. He's very proud of this bit of knowledge.
So, but okay, these 2 buttons, all this does is this plays with time. So I can go all the way from my lowest is, my highest is, 500 seconds, really? I don't know when I would ever use that.
To be clear, that's an up and down button, but what it's adjusting is actually set with the 4th button at the bottom.
Right, exactly. So I can set my how quickly I want to measure, and then when I hit that, I can commit it. There we go. So what I did is I also built this. This is a signal generator, which will allow me to actually measure something with my oscilloscope. Oh, if I can find
something
probes.
To measure. Yeah.
Yeah. There we go. Normally I would tie this in, but I'm being really lazy, so I'm just going to do...
You?
I know, right?
What?
Very rarely does that happen. And I totally screwed up my scale. Hold on. Wait, come back.
Oh, God, epilepsy.
I know.
What are you doing?
Hold on,
You're killing the screen.
Sorry. Okay.
You're on hold.
Yeah, I can't. I'm running out of fingers, Smitty. And you know
Make it work.
Just reset it. It was easier that way.
Have you tried turning it off and on again?
My scale is all the way off too. Oh, there we go. So I'm at 5 milliseconds, and
that's 5 seconds per division.
Yes. Oh, I'm at 5 seconds. Jeez, no, I don't want that. Oh, there we go. So now you're actually starting to see the wave.
You're on DC though. Switch it over to AC so you don't have to center it.
I also want to increase my scale. There we go. So you're actually seeing the wave being generated by the signal generator. And I can play, if I can get my fingers down to the knobs, I can actually play with the coarseness. I can play with the amplitude just by adjusting this. This was something else I picked up from Banggood. I think this was like $3, $4. I would suggest you pick it up just so that you can see whether or not your oscilloscope is working. But this works fine. I mean, if you just want to measure voltage, if you want to see if you're getting signal from your RC devices, this is a really good way to actually see what's going on. And then you'll understand what people say when they're getting really dirty signal.
Yeah. Actually, for testing out your oscope, can you go ahead and switch the camera to me? At the top of the scope, right here, there is a little wire. I can't hold it up and look at the screen at the same time, unfortunately. At the top of the board, there's a little wire hoop up here that's reachable through that hole. Nope, that's power. That hole right there. Yep. Hang on. There we go. You can see that little wire loop right there. If you stick a probe onto that, what that little loop is just a test point. What it does is it generates, I believe, a 10 kilohertz 3.3 volt signal. And so it's just a 10 kilohertz square wave. And you can use that to, well, it's a square wave. What you actually use it to adjust the compensation on your meter probes. But this thing didn't come with meter probes, and they're not compensatable, so I don't know what the heck that's there for. But you can do that, and that will let you test out your oscope. So you know that if you see that 10 kilohertz 3.3 volt signal, that it's working.
There you go. There you go. Now, Brian, you're going to continue working on your oscope. You're going to be able to assemble that at some point, hopefully, and you'll show it off.
Finishing organizing my resistors because I finished this. So can we test to see if this works? Or,
well, I'd have to open this up.
Oh, I thought we were gonna see if I'd done it.
We were gonna
good.
attach it to this, but I didn't finish it.
You done it good, Brian.
I feel like I'd done it good.
I trust you.
Okay, cool. Thanks.
Okay.
I believe in you.
I feel better now.
Padre may not, but I believe in you.
Smitty, thanks. Thank you so very much. It really does help to have someone who actually does this in the real world, because it helps us to know that we're on the right track.
Yeah.
Yeah. Oh, Brian.
Padre.
The next project that we're going to be doing with Smitty is this.
What is that?
This is a little, it's an Unz machine, but what it is, it's actually a SMD kit. If you go to my product shot, all of
what
these.
What does SMD stand for?
Surface mount. This is a surface mount, and what this allows me to do is it allows me to do some of the more challenging kits. Every component on this came in a bag, and it had to be soldered on, and there are no through holes. This is a technique that I was deathly afraid of until Smitty told me that I could do it. And he gave me some tips on how to put this thing together. And actually, let me see if I can power this thing up. I'm going to have to play Jenga over here, shut down everything without accidentally burning myself because the iron is still hot.
Do you smell chicken, Padre?
I always smell chicken.
Nom, nom. I haven't had dinner yet.
As long as
there we go. Thank you. Yes.
Yes. Kara knew where we were going to go with this episode.
Well played.
Kara,
are we predictable? Is that the problem?
We are a little bit predictable.
Not us.
So what we've got here is we've got a way to actually do the frequency. It can show us the frequency response of the, what do you call it? What do they call those things?
Spectrum analyzer.
Spectrum analyzer. Thank you. I need a song. Hold on. I get a Brian.
Work.
Is my not enough?
Oh, hold on. So what we have here is this little SMD kit takes whatever source is coming in. In this case, it's YouTube playing a piece of music that I think a lot of our fans know quite well, and it's showing me the spectrum. This is a spectrum analysis from low frequency all the way to high frequency, and that's done by a series of surface mount LEDs that I've attached to this board through this. This is the chip that does all the magic. So when we get this kit, we're going to give you the link, and you'll be able to solder everything from ICs to resistors to capacitors, and of course, a lot of LEDs. By the time you're done with this, you'll be an expert at SMD. What do you think, Smitty? Do you approve?
Absolutely.
This is actually kind of cool. I have this thing running on my desk all the time.
What size are those? Do you know?
What size?
805s, 1206s? What size are the SMD components?
That is a really good question. I could not tell you that.
Okay.
We'll find out as soon as you get a kit.
Sounds good. They look like 1206s, which are relatively large and easy to do.
I did have to use tweezers because my fingers kept trying to.
Well, yeah, we've got sausage fingers. We're big gentlemen. For anybody who is interested in buying one of these kits to build along with us, I highly, highly, highly recommend you get a set of tweezers too.
Yes.
Yes, I can do surface mount without tweezers, but I kind of try not to give myself second-degree burns on my fingertips. Highly recommend to get tweezers. It's much, much, much easier and faster and better and everything else.
Second-degree burns are your friends.
It's not a project until you've either burned yourself or bled on it.
Yes, or released blue smoke. Then it's really a project.
Yeah, we try to avoid that.
We do.
Burns, whatever. I heal, but we don't want to destroy the components.
Smitty, thank you again so very much for being our guru of all things electronic. If the folks at home wanted to find out what you're doing, I know you've got a YouTube channel now, and people actually come by. Tell me about it.
So I am Smitty Halibut on YouTube, and I have been streaming some work that I've been doing on some projects. So I looked at Twitch, the business model behind Twitch, and like people watch other people play games. Maybe other people would like to watch me do what I do in the evenings, and that is, lay out circuit boards and do things like that. And I tried it, and lo and behold, I got a bunch of people following me and watching and joining me in the chat room while I'm doing stuff. So probably the best way is to follow me on YouTube if you are into that sort of thing. Again, it's Smitty Halibut, SmittyHalibut, just like the fish. And I believe YouTube will notify you when I start streaming. The other option is to follow me on Twitter. I am also Smitty Halibut on Twitter, and I usually, when I remember, post on Twitter of like, hey, I'm going to be starting a stream in a few minutes, and then when I do start it, and then I post the video when I'm done.
That's Mark Smith, Smitty Halibut. Again, he is our spirit animal. Brian, I know you're.
How you doing over there?
You're kind of.
What's up, Bri?
What's going on, man?
Okay, one quick question, Smitty.
Yes, sir.
So I thought that this was 3K. Am I not on the right?
No.
So you're at 2K, and that's 298, so that's 300 ohm, not 3K.
300.
That's 300 ohm.
Okay. Cool. All right, 300 ohm. That's the one I was
And
missing.
this is why you're going to measure it again before you actually add it to the board.
No, it's fine. It's fine.
Just
Look,
in case.
It'll be fine, I'm sure.
That's all of them. They're all in there. I'm going to double count them and probably double check them, yes, but we should be good.
All right, until next time, I am... Wait, no, we haven't told them where to get everything. Don't forget that you can get all of our show notes at our show page. Where do they get that, Brian?
twit.tv/KH and download, subscribe. And if you want one of these kits, you're going to want to go there so you can find the link to that.
Yeah, and also I'll post pictures of the time that I almost blew one up because that was kind of funny. Also, don't forget that you can find us on the socials, specifically on Google+. Just go to Google+ and look for Know How. Once you're there, you'll be able to join after a quick approval process that we use to keep away from the cam accounts and all the spam folk. And you'll have access to about 11,000 Ketas. That's our know-it-alls, people who can answer questions, people who can ask questions, people who can maybe give you an idea for that next cool project. It's part of a community. It's part of who we are as makers and DIYers. Again, go to Google+ and join Know How. But that's not the only place they can find us.
Not the only place. If you want to see what projects we're working on or behind-the-scenes look, you're going to want to go to Twitter. I'm at cranky_hippo.
And you're going to find me at Padre SJ. And you're going to find our director, Kara Cole. Kara, what's your Twitter address?
It's at Kara080. I hardly tweet, so you won't be annoyed if you follow me.
So much attitude over
That is
there.
probably one of the best sales pitches I've ever. Follow me. I won't bother you.
Follow me. It won't be annoying.
Okay, now, until next time, I'm Father Robert Balacer.
I'm Brian Burnett.
And that's Mark Smith, Smitty Halibut. And now that you know how...
Go oscilloscope it. Fist bump, Smitty.
Fist bump.
Mighty
Jellyfish.